we started talking about the CRJ-700 and the little bundle of joy it is. We talked about how it was technically, well, it was a Challenger private jet. They just cut the fuselage, made it longer, and put a little extension in, and then a little bigger engines on it, and that's pretty much what a CRJ is. So CRJ stands for Canadair Regional Jet. So all right. So just some key points to go over. The CRJ-700 meets the most stringent FAA noise requirements. They're pretty quiet for the, for the size. They don't really have too many problems with the noise abatement and stuff like that. So due to the height of the tail section location of the APU, there's no danger area for the APU exhaust. So on the 200s, there's a little exhaust vent back here, and it will blow like extremely hot air exhaust, out of the back of the jet right there, low to the ground. Remember that the door seal here, the bottom of that door seal is 4'7", so 4'7" off the ground. So you can imagine that APU exhaust vent is about that same height. So if I walked by it, it would blast my chest with piping hot exhaust. You can see on really cold days, you'll see the rampies standing about 10 feet back from that area, warming their hands up. But you don't want to get too close. There's actually on the publication for the CRJ-200, there's like a red "do not walk in this area" when the APU is running because of how hot the exhaust gas is. But on the 700, they changed the exhaust port for the APU clear up to here, right at the base of the tail. And we'll get into it a little bit more, but the APU is basically another jet engine. I mean, it's not producing thrust or anything, but it's generating power, and so it's a pretty big engine. It's just not, a jet engine, but still produces pretty extremely hot gas. This is equipped with one aft lavatory. The 900s have a forward and aft lavatory. The flight deck door is reinforced, carries 19,594 pounds of fuel, and capable of ranges up to almost 2,000 nautical miles at Mach 0.74. So, somebody want to explain what Mach is? I know we got some aviation nerds.
Mach is the speed of sound, 600 plus.
Okay, so depending on our altitude, the speed actually changes. But yeah, so the speed of sound is what Mach is. So when we say 0.74 Mach, that's saying basically three quarters the speed of sound. And depending on our altitude, that changes. So Like I said, up at 27,000 feet, the CRJ, you look at the indicated airspeed and it'll say 285 knots. But you look at the ground speed and it'll say 525 miles per hour. So you're actually, or 525 knots. So that's how fast you're moving across the ground. So, um, that's a pretty good clip. Um, Depending on a headwind or a tailwind, things change, but yeah, Mach 0.74 is 3/4 the speed of sound. Many systems have been improved and other systems have been automated. It's talking in reference to comparing it to the 200, the CRJ-200. The engines are 2G General Electric CF34 8C1s, or some of them are equipped with an 8C5B1. So depending on, if it's these 8C5B1 engines are just a little more efficient than the 8C1s. These came out first. The 8C5B1s are a little bit newer, little more efficient, get a little better gas mileage out of them, and they produce a little more thrust. But normal takeoff thrust is about 12,670 pounds. So that's a lot of horsepower, Each power plant is controlled by a full authority digital engine control system, or also known as a FADEC. So a FADEC is kind of like the brains of the engines. The FADEC is basically digitally controlling the engines. The pilot can slam the throttles in the aircraft. He can slam them all the way forward. But the FADEC is actually going to control, regardless of the position of the throttles, the FADEC is going to control the amount of thrust and how quickly it's applied. So depending on certain things, the FADEC will read all different kinds of engine temperatures, N1 speed, N2 speed, things like that, to adjust and make sure that the engines are producing that thrust efficiently and, in a way that makes sense. So the leading edge slats. So let's go back to this picture. So the leading edge slats, they're up here. Provide improved handling capabilities at lower airspeeds. So they can deploy the slats and it basically changes the shape of the wing. Did we already talk about wing shapes and stuff like that? Feels like
like with the winglets and stuff.
Even more so, like the actual side profile of the wing. I'm pretty sure we talked about it the first week.
Well, talked a little bit about angle of attack and things like that early on.
Mm-hmm. Yeah, so
I think we did. Yeah.
Yeah, so the slats drop off the front. You've got the flaps and the slats, and they'll drop off the front of the wing. The flaps drop off the back of the wing, and basically make a bigger arch in the wing, so it is, grabbing more air, provides a lot more lift. Oh, I'm sorry, I'm thinking spoilers, but the slats are in conjunction with the ailerons. They'll move with the ailerons to improve that low speed maneuverability. The electrical system is more powerful and simplified. The pneumatic system has also been simplified, again referring to or comparing it to the CRJ-200. The thrust reversers are hydraulically operated. On the 200, they're pneumatically. So hydraulically, everybody knows what a hydraulic is, right? I don't need to explain that. So
Sure.
So hydraulically, basically, there's a fluid that is operating the thrust reversers. It's fluids ran through tubing, and it's almost like a mechanical linkage between the control and the thrust reverser. So when we say pneumatically means that it's air driven. So it'll actually take the bleed air off the engines. It'll take exhaust off the engines, basically, and use that air to deploy the thrust reversers. So hydraulically means it uses a liquid. Pneumatically means it's air. What was that?
Perfect. Got it.
All right. So the 700 has a cargo compartment installed in the forward part of the aircraft, left of the wing, or of the left wing, sorry. So of the FO side of the aircraft. So the 200 only has an aft compartment. The 700 has both the aft and forward compartments. And if you want to see where they're at, so the aft compartment's back here, forward compartment's up here. Okay. Oops.
Both are on the PIC side.
Oh, that's right. That's right. I'm sorry. Left wing. My bad. Okay. Good catch.
Unless you're flying in England.
Yeah, that's right. That's where I got messed up. I was thinking England. All right. So,
Good save.
what was that?
It's a good save.
So, the automatic flight control system provides integration of the flight director and autopilot systems. So, just like the name says, automatic flight control system. It's working in conjunction with the FMS or the flight director and the autopilot. So those are working with each other to maintain certain inputs that the captain puts in or the pilot puts in, whether that be altitude, heading, speed, one of those things, or all of them. It's going to work with the navigation system in order to guide the aircraft. The AFCS controls supply information to the dual independent flight directors, the 2-axis autopilot, automatic pitch trim, and independent yaw dampers. So, yeah, pretty much just what I said. So it'll the pitch trim on the aircraft on the tail here. There's little control surfaces on the very edge of the. Remember, this part is called the elevator. So there's little tiny elevators on the elevator, basically, and we call those trim tabs. The trim tabs will deflect the air just enough to relieve the controls on, the pilot and co-pilot's controls, the pressures on the controls. So they can basically tune in the aircraft. They can adjust those trim tabs to where they can let go of the yoke or the stick, and the aircraft will fly straight, smooth, perfectly without any problems. Without those trim tabs, depending on how the aircraft's performing, where the weight in the aircraft is, things like that, it could cause a lot of extra work on the pilots to keep the aircraft under control. So the trim tabs just relieve that pressure off the control, and this AFCS basically automatically sets those trim tabs to manage that. And the yaw dampers, just the same thing, but on the vertical and not the horizontal. So Autopilot servos provide command inputs to the ailerons and elevators. So it's controlling the pitch and roll of the aircraft. The rudder is controlled by the yaw damper system. When the autopilot is engaged, the AFCS maneuvers the aircraft while the pilot monitors the flight path. So basically, the pilot sits there and watches a computer do its magic. Once he sets the altitude, sets the route of flight into the FMS, flight management system. Once he sets those things, the altitude, the speed, and the flight plan into the FMS, and turns on the autopilot will take care of everything. He's just there in case the autopilot messes up or stops working. Then he'll actually have to do his job at that point. Really, a pilot gets paid, 50, 60, 70, depending on who they're working for, that much money to monitor a computer system and occasionally land or take off.
Where do I sign up for that?
SkyWest Pro. Bountiful flight. Oh, believe me, I've looked into it. But APU key points, it's built by Honeywell. It's a Honeywell RE220 APU. APU, remember, stands for auxiliary, and write this down, please. APU stands for Auxiliary Power Unit. So remember, we have two what we call IDGs, integrated drive generators, that are driven by the two jet engines. So IDGs, write down IDGs, integrated drive generators. Those are the primary source of electrical power, AC electrical power. Okay. The backup is the APU, the auxiliary power unit. Okay. So we're going to be using these terms a lot, and you're never going to stop hearing about them, because every single jet turbine powered aircraft has some sort of AC electrical power. Depending on the aircraft, it may be a little bit different, but for the 700, its two IDGs are the primary, and the APU is auxiliary or backup.
Garrett, does the 700 and 900 have ADGs?
The 200, 700, and 900 all have ADGs. And what those are basically it's, and we'll go over this, but it's basically a propeller that will drop out the front of the aircraft, and it acts as a windmill, and it provides like backup power, emergency power is what we call it, in case all electrical power goes out on the aircraft, both IDGs and the APU. The ADG will power only necessary parts of the aircraft to get it down on the ground, basically. But it's just a little windmill that pops out the front of the airplane, and we'll show you what they look like. But are you thinking of rats or something? Ram air turbines?
No, just was curious about the ADG. I knew the 200 had them. I didn't know if they'd modified it with those IDGs or if they had something like that for in-flight electrical needs,
Yeah.
backup power.
Yeah, so
So when you say that the ADG is powering things that are necessary, what would that cover?
basically the flight display for the captain, and then the controls for the hydraulics. It powers the 3B pump is what we call it. So basically the elevators, the ailerons, the rudder, and just a handful of electronic systems to support those so that the pilot can get the aircraft onto the ground. Basically, if you lose to the point where you have to deploy your ADG, you're getting on the ground as quickly as you can. So,
Got it.
the secondary function of the APU is to. Did I cover all of those? Oops. No, sorry. Okay. My bad. So the APU has automatic fault detection. So it'll automatically detect if there's a fault in the system, and it'll shut down to make sure that it doesn't overheat or destroy something. And in the event of an APU fire on the ground, it's got automatic fire extinguishing protection. So it's got a halon bottle that'll blow up in the APU compartment and extinguish any fire. The primary function is to operate a 40 kilowatt, 40 kilovolt generator. So yeah, the secondary function is to provide or supply bleed air for air conditioning and engine starting. So this is the really important part of the APU. Well, this screen has, take a screenshot of this and study this, because the APU and these figures, when you actually get to, say, SkyWest, are actually different, because of different, basically trial and error that we've had with the aircraft. There's been times where we've had extra problems from trying to operate an APU at 37,000 feet.
So it's supplying that bleed air to those forward-facing parts of the aircraft that you had indicated when we were looking at it.
So that's not its job, really. So,
but it's secondary.
So the supply of the bleed air is for engine starting only. It'll provide backup if the IDG fails, or if one of the engines fell. I'm sorry. It can provide backup bleed air, but its main purpose is to provide bleed air for engine starts. So whenever we have an APU deferral, like the APU is not working on our aircraft, we need to call the station's downline, or really we talk to the system controller because it's the system controller's job to check this, but basically we have to ensure that all of our downline airports that we're going to be landing at have what we call an air start cart and a GPU, ground power unit. So if they don't have those things, once we land and the pilot shuts off the engine, then we're toast. We cannot get the engine to start. We have to have that bleed air to crank the engine. You guys ever see the videos of like the really old school videos of guys starting propeller driven aircraft? They grab the propeller.
Like they have to spin the prop.
Yeah, they run out there,
Yeah.
and it's black and white, and you've got some dummy out there standing right in front of the prop, grabbing it and starting the prop. That is the same thing that the APU is doing for our jet turbine. It's spinning those fans inside the engine to a point where the engine is doing it itself. Does that make sense?
It's like a manual transmission and pushing it down the hill so you can pop the clutch.
Exactly.
Okay, got it.
So yeah, if you have to think about driving a stick shift, and having somebody push you while you pop the clutch and get it started, or some wingnut out there spinning a prop, either one of those, that's what it's doing for the engine. It's providing that initial start for combustion for the two primary engines.
So if it's the start of the day and that happens, and there is a station that doesn't have a GPU, do we do an aircraft swap? Is that?
We can do an aircraft swap. We can tell maintenance they got to fix it. There's a couple different options.
Okay.
Or we'll just have them, rather than flying, an aircraft swap, right?
Okay.
So yeah, and that's all the system controller that's going to be taking care of that for us. Basically, our job is to notify the system controller and say, hey, have you double checked to make sure that, Raleigh-Durham has a GPU and air start.
Very cool.
And if they say no, then you say, all right, I need you to swap my aircraft or tell maintenance to get on it, whatever it is. So maximum operating altitude. This says 41,000 feet. The maximum operating altitude at SkyWest that we will allow for planning purposes on the 700 is 37,000 feet. Actually, no, I take that back. 36,000 feet. We can only plan to 36,000 feet. So this is the manufacturer's. What I'm trying to point out is this is the manufacturer's checklist. It's not SkyWest's. So if you go to SkyWest and you're learning the 700, don't be like completely flabbergasted. But I thought it was 41,000 feet. Anyways, sorry, tangent. I know. Bleed air use limited to 25,000 feet and below. APU burn. This is the important one here. Is this APU burn? After this. So this one, primary importance. This one, secondary. So if we have an IDG fails, remember we have two of them. one on each engine. If one of them fails, then we have to continuously operate the APU during our flight. Okay? So that's the reason why we have this APU burn of 260 pounds per hour. Another reason is, let's say the fueler jumps on and overfills our aircraft with way too much fuel. And now the captain, when he runs his numbers, he's over his maximum takeoff weight because there's too much fuel on board. He can crank on his APU and just burn his APU for, he'll crank on his APU, then he'll crank on his engines and he'll burn the snot out of his gas. And sometimes they have to just sit out in the timeout box for like 20, 30 minutes and burn fuel because they put too much gas on the airplane. But
Okay, side note,
uh-huh.
Who foots the bill for that?
Mainline.
Oh my goodness, that's inefficient.
Yeah. Yeah, it sucks. But there's times where it's like, when we do that would be in scenarios where it's like you're at Detroit, let's say, and Detroit says the fuel truck can't get out there to defuel the aircraft for an hour. And you know that in 30 minutes we could burn off enough fuel for him to take off. What are you going to do at that point? Are you going to go and burn for 30 minutes? Or are you going to wait an hour for the fuel truck to come out? So
Right.
that's when we would apply it.
Got it.
All right. So communication key points. We got audio integrating system, control panel, speakers, headset, jacks, oxygen mask, microphones, etc. So basically everything that you need to talk to air traffic control or whoever you need to talk to. There's also a PA system and then radio tuning systems. They've got a little display that has all of their radio information on it. And then a cockpit voice recorder. Any 121 aircraft will always have a cockpit voice recorder. And as you read through your ADX, the ADX says, how long must the cockpit voice recorder record conversations in the cockpit or whatever? You have to have at least the last 30 minutes of cockpit voice recording, stuff like that.
A question for jump seat, Garrett.
Uh-huh.
Do you carry your own headset, or do they provide you one?
When you're jump seating?
Yeah.
They provide you one, but it's a little Radio Shack $5 headset that sucks, and it actually doesn't have a microphone. It is only audio, passive listening. So I bring my own headset on the aircraft.
Is it just a normal 3.5 millimeter jack?
No. So it actually has the really big ones. I can't remember what they're called. But it's got...
You're talking about a 1/4-inch jack like are in the ones that I use in the Cessna?
Uh-huh, exactly.
That would make sense.
So it's got a microphone one and a headset one. So it has two different jacks on it. And if you guys want, a lot of dispatchers buy their own headsets. So you can just ask around in the office and be like, hey, can I use your headset? I'm going jump seating. And most of the time, people are cool with it. Or you can buy your own headset if you really want, or just use the Radio Shack ones. So.
And just to jump off on another tangent really quick, I know everybody's probably tired of hearing my voice at this point. However, audio integrating system, oxygen mask, microphones.
Yeah, so
that's a thing.
Yeah, so in the event that the cabin is depressurized, and they have to put on their oxygen masks, or let's say the cockpit's filling up with smoke and they have to put on their oxygen mask, they would have to take their headsets off in order to do that.
Okay, but that's just for the cockpit crew. That's not for everybody in the cabin,
No.
right?
No.
Okay, I'm just making
Well,
sure.
Everybody in the cockpit. So, if it's an additional crew member like a jump seater or whatever, there is one oxygen mask with microphones in it for each seat in the cockpit.
Okay, copy.
And I also believe that the flight attendants have one as well. I can't. I'd have to double check on that, but maybe I'll ask that the next time I'm up there.
But that would make sense, yeah.
Yeah.
Okay, cool.
And did you guys watch the video of the Southwest accident where the engine blew up and the guy was recording himself with the oxygen mask? That's not how you wear an oxygen mask. He's like just covering his mouth. It's supposed to go over your mouth and nose. You can see him just breathing into this mask with just over his mouth.
Right.
The person that doesn't pay attention to the emergency announcements before the flight.
Yeah, and that's why Southwest, even still, even with how exciting their introductions or their safety instructions are, you still have people that just don't listen.
But it's like a parent. It's like, do what I say, not what I do.
Yeah. Yeah. But some other things that it has is a service interphone system. So you can see the flight attendants pick up a headset and talk to the pilots every once in a while. That's the service interphone system. And then VHF communication system, that's air traffic control and stuff. The ELT, or emergency locator transmitter, required on every aircraft. Basically, if there's a hard impact, it'll set off a beacon and to the Air National Guard. And basically what it is it's like it transmits a point for the point of impact. So if there is a crash, they can find the crash quickly. So the ELT will transmit a signal for so long, and help air traffic or help search and rescue find the aircraft. And then the flight data recorder. So flight data recorder does a whole lot of things, but yeah.
Garrett, is that VHF range going to be on the same data range that was indicated in the ground-based navigation section?
Exactly. Yeah.
Okay.
So, yeah. So some door, key features. There's 9 external doors. Every time I talk about this, I start thinking about the flight attendants. 2 forward doors, 2 overwing exits. Them pointing at the doors and stuff. Forward cargo bay door that we already talked about. And the pilot on the ICAS, one of the screens up in the cockpit, they have what we call synoptic pages on them, and we'll get into this too. But these synoptic pages, they can flip to a page where it shows all the doors, and all the doors have sensors on them. And when all the doors are closed, They'll show up as green lights on the aircraft. So it's kind of like on your car when it says left rear door open, you know. It's just like that for the pilots in the cockpit, so they can see which doors are open and which ones are closed.
I'm sorry, my car doesn't say that.
But yeah, you got a 1989 Toyota Corolla. Just teasing.
No, I don't.
Okay, thanks, babe. Some of the electrical key points are what we've already talked about. So it's using both 115 volt AC and 28 volt DC power. So you've got the AC DC rock on. What's providing the primary source of AC power is the two engine driven integrated drive generators. So please make sure that you write that down. So primary source of AC power is two engine-driven IDGs. That will be on your practical test, 100% guarantee it. So the constant speed drive, or the CSD, turn the IDGs at a constant RPM. What you need to compare the CSD to is a transmission. Basically, it's the transmission for the IDGs. It keeps them producing constant power, because if one spins too fast, then it's going to have what we call a oh my gosh, I just lost it. A spike in power, and those spikes can like blow circuits and stuff like that. So the CSD is a pretty important part of the whole system. The CSD is the transmission. Okay.
Do we know what that constant speed is, or it's
really,
like self-regulating?
I'm not too sure. It's really not too important. Just
Okay.
the important thing is that it's consistently providing that 115 volts of AC power.
Got it. Okay.
So yeah. The APU provides alternate source of AC electrical power. Remember, alternate APU, auxiliary, whatever you got to do to remember that it's the backup. The ADG provides an emergency source of power. Okay, so let me show you guys. Let me close those down really quick. Where are we at? We'll go Safari for this. Not the App Store. Not Mail.
What was it that you were saying about Max earlier? I'm sorry, what?
I get it.
So is ADG auxiliary
Air-driven.
drive
Nope.
air-driven generator?
Yep, it's the air-driven generator. So
Okay.
it's a windmill, basically. This is kind of what it looks like. Let me make it big. So this little door will pop open on the nose of the aircraft, and this little thing will fly out of there like a bat out of hell. and just starts spinning that turbine there. And this is kind of like the CSD. It's generating the power. It's a motor, basically, and it's generating the power and keeping it at a constant rate. So these things, like I said, they release when they deploy the ADG. It comes out really, really fast. And like, there's been people that have been seriously injured because, you know, the pilot accidentally deploys the ADG while it's sitting on the ground and somebody's standing next to it. But yeah, they pop out in the flash of light. So on some aircraft, you'll see this referred to as a ram air turbine. They're basically the same thing, just called different names. They function just a little bit differently, but really the CRJs, what you need to know is that it's called an air-driven generator, or ADG. And this is emergency power. So think of it as like a windmill. The ADG can deploy automatically when both main buses are without power and may be deployed manually. The ADG power is distributed to the flaps, slats, pitch trim, hydraulic 3B pump, and the AC essential bus. So there you go. That's what it's powering. Basically, the absolutely most important, most essential parts of the airplane. DC power is provided by 4 transformer rectifier units, or TRUs. We don't care about those nearly as much. You also have 2 NiCad batteries that store and provide a source of DC electrical power for normal and emergency operations. AC and DC power systems utilize power centers to manage power distribution. Basically, it's like it's right behind the pilots. It's just a wall of circuit breakers and crap. Tangle of wires, rat's nests, whatever. AC Power Center, ACPC, distributes AC electrical power to 4 AC buses, and then the DCPC distributes the DC electrical power to 9 DC buses. So the buses aren't big yellow buses that drive kids to school. What it's talking about is like a panel of circuit breakers, basically. It's a bus is like it'll supply the bus with power, and then the buses go to the individual different components of the aircraft.
You can compare a bus to similar to the fuse box in your car.
Yeah, exactly. So the environmental control system, this is what everybody loves in the aircraft, all the passengers. This will make or break a flight, right? Environmental control system. So this is what we call air conditioning. Yay! Environmental control system provides regulated conditioned air to the flight deck and passenger cabin. There's 2 AC packs. So kind of important to know that there's 2 AC packs. The left pack supplies air to the flight deck, and the right supplies air to the cabin. So basically what this is saying is if we have a deferred right pack, the pilots will still fly the aircraft, But if the left pack is deferred and the right pack is working, the pilots will reject the aircraft. They don't care if the people in the back are hot. They just have to be cool, right? Forward and aft cargo bays are pressurized. Only the aft cargo bay is ventilated with conditioned air. So we can't put doggies and ponies and goats in the forward cargo bay. Conditioned air from the packs is blended with filtered recirculated air to optimize ECF's performance. So the recirculated air can be up to 34% of the total airflow. Single pack operations limited to 310. That's very important. Okay. Whenever we have one pack deferred, we are limited to 31,000 feet, or flight level 310. 31,000. Two dual-channel system controllers, ACSC, monitor and control the air conditioning systems. Okay, what do we do when there's a fire? Land the airplane.
Stop, drop, and roll.
Yep. So the two subsystems, fire and overheat, detect fire, overheat, or smoke conditions. The fire extinguishing systems contain contaminant and containment. Oh my gosh. Containment and delivery of an extinguishing agent to protected areas of the aircraft. Halon. That's what it's called. Halon bottles. So halon basically suffocates the fire. And it's a gas too. So, like, think if it was like fire extinguishing fluid, that wouldn't be good. Because then it causes a lot of damage to engine components. If it's a gas, then it doesn't completely destroy the engine. So it's all controlled by the Fire and Detection Extinguishing Unit, or the FIDEX. Fire and overheat areas of protection. The main parts are going to be the engine, APU, and main landing gear. Why the landing gear?
You don't want your
Gotta land
tires.
the plane safely.
What was that?
Because it gets so stupidly hot.
Yeah.
And oil.
So have you guys ever seen a what do they call it? A Mach. It's basically when they test the brakes. Have you guys ever seen one of those videos on a 747? Okay, no. No means you guys get to watch a video because it's just that freaking awesome.
We've had to put the air cart directly on the brakes
On the
to
brakes.
have them
cool
cool down.
Yeah.
Yeah.
They get roasty toasty, and some pilots don't.
Kind of like the opposite of the video. We're in Russia. They had to put heat on it. We had to put air,
Right.
cool air on it.
Yeah, it's oops. RTOs, that's what they call them. Oh, that's a 777, but we'll take it. Still big and amazing. Okay, everybody watch that video real quick. Pretty sweet, huh? So landing gear get freaking hot, especially when captains don't like to use their thrust reversers, which I think is silly. But whatevs. Yeah. So when they get that hot, got to have a way of protecting, systems here. So there's smoke detection, forward and aft cargo bays, 3 forward, 2 aft. Lavatory has ceiling mounted smoke detectors. And it's a bad day for anybody that jacks with those. They'll even pick up vape smoke. Like, they're pretty sensitive. Engine fire and overheat protection detects fire and or an overheat condition in an engine nacelle. Two extinguishing bottles for engine fire. Both bottles can be discharged into either engine. So there's like a little hose that goes into each engine, and there's 2 bottles in the center of the aircraft. Basically, they can put both bottles into one engine, or they can do both engines depending on, how bad the fire is. Oh, excuse me, and which engine's being affected. On the ground, the APU will shut down automatically and discharge the halon into the APU compartment when the fire is detected. In the air, the APU shuts down automatically, but the crew must discharge the halon bottle when fire condition is detected. So, slightly different. 2 cargo fire extinguishing bottles, one for immediate discharge, and then the other one does a slow discharge. There was a 747 that crashed due to the cargo bay. They were transporting lithium-ion batteries, and they had what's called a runaway situation. Basically, lithium-ion batteries have multiple cells inside each lithium-ion battery. So one cell will, let's say, the box catches on fire, one cell may go, but due to the damage caused to the other cells, there's a delayed reaction, and that's why they call it runaway. Because what'll happen is, eventually that damage, they may put out the fire, but eventually the damage to the other cell will cause that cell to ignite spontaneously, and then so on and so forth. So, does anybody watch Top Gear? I love Top Gear. They had an episode where one of the hosts of Top Gear was driving an all-electric car. He crashed it. It's like a multi-million-dollar car. He crashed, and the car was all electric, and they put it out initially. They said that the car continued to spontaneously ignite for 7 days. That's how bad lithium-ion batteries are. And that's why, if you do have a lithium-ion battery, you have to carry it in the passenger compartment, and they have a special bag to put the battery in if it does catch on fire. Because if it's in the cargo bay, sorry, Charlie, plane's going down. Um. Oh man, sorry guys. Oh, it is bedtime. We will stop right here at flight controls because that we just barely got here. So we'll just call it a night. That's 36 out of 130 slides. So
Garrett,
yeah.
for our brief after hours or after class session that we're going to do,
Uh-huh.
can we record that too for those who can't stay on?
Yeah, for sure.
Okay, cool.
Any other questions?
When is our next quiz and what will it be on?
So the next quiz will be systems, and it will be next week. So next week, probably Wednesday, once again, we'll have another quiz. The systems quiz will be pretty short too, but next week we'll also start meteorology and start going through weather. That's like the last huge subject that we have to cover. So once we cover that, we will start doing practical dispatch applications. So we're talking the end of week 5, week 6. We'll start with the practical dispatch applications, and then 7 and 8 will of course be in class. Now I've hit Adam up multiple times now. He's trying to get a hold of the guy that runs the school down in St. George to allow us to meet one night a week. Sorry. And he hasn't responded. So I'm just going to make it available to where, as if anybody needs extra time on weekends, we can meet at the Dixie State Library and go over stuff. I'll just need to know like a day or two in advance. So we'll just plan on doing it either Saturday evening or Sunday evening at Dixie State. Just extra hours for anybody that needs it. Does that sound good?
Would you rather do a set time for that, either Saturday or Sunday evening, and then if there are no takers, then you don't have to plan on it?
Yeah, that's fine. And I'll have to take a poll. I mean, what's more convenient for everybody, Saturday or Sunday night?
Sundays are more convenient for me, but I'm easy.
Okay.
I'm good either night.
Sundays are good for me, Garrett.
Okay. I haven't
And
heard.
me as well.
Okay. So let's just plan on, like, if people want to do a extra study session on Sunday nights at 5:30 or 6. Which one? 6 is a nice round number. We can spend an extra hour or two at the Dixie State Library and just go over information that we maybe need a little extra time on. And I could probably record those and put them online too for people that want to watch them. But
That's open on Sunday. School out.
You're right. Mm,
We could go to the actual library.
are they open on Sundays?
I
Mhm.
have no idea. I would imagine so. Let me ask Google. One moment, please.
The Dixie Library might be open for the summer semester.
Yeah, I think our chances would be better with the Dixie. I think the public libraries are closed Saturdays and Sundays. But we'll set up a for sure time Friday at the end of class and I'll get a list of people that would be interested in doing an extra study sessions on Sunday.
It says 2 to 10 for the Dixie University.
Okay, perfect. They've got nice facilities there with good
And the Washington
Wi-Fi.
County Library is closed on Sunday, so.
Okay, so we'll just on Fridays every week we'll just open that up, and basically if I can get 2 or 3 people even to show up for a Sunday study session, then we'll call it a go. So
Cool, that's great.
Text or via email.
I'll just ask everybody on Fridays at the end of class. Sound good?
Yeah, sounds great.
Okay.
Appreciate the extra time.
Yeah, no problem. All right, guys. That's the end of regular class. If anybody wants to stay after for a couple minutes, you're more than welcome.
Got a quick
Guess that's
question
no
for you.
Eric.
I wanted to go back to the head.
With you guys.
Good night.
Good
Good night, all.
Good night. Just a quick question regarding the headsets up there in the jump seat.
Mm-hmm.
I kept my David Clark set. Is that something that's outdated?
Oh, no. DCs are probably the most popular headset still. So the only thing I tend to see are DCs or Bose headsets anymore. So when I show up,
Sweet, I know whose headset I'm going to borrow when I need one. Thanks, Rex.
As long as you don't spit into the microphone.
yeah, they're kind of like the tanks of the industry. They're extremely reliable. Good headsets.
When I bought the 182, the guy that whose share I was purchasing said, "Here, I'll throw this in," and I didn't offer the same benefit to the guy who bought my share.
Yeah, they're good headsets.
Indeed.
Yeah. So, is there anything in particular that you guys wanted to talk about? I mean, talking about the navigational aids and answering the previous question. You know, I like Wikipedia for some things, Cody, don't get me wrong, but when it comes to aviation, there's a lot of stuff that's probably going to be missing or not relayed correctly. So, I would try to steer away from it, but one good resource to go to would be this Sky Vector, and you can type in any like major airport, and that will give you a list right there of navigational aids. ILS localizer, you can go to LA and pull up. You've got RNAV, ILS localizer.
I guess, Garrett, what I'm having a problem with is that there's some overlap between our ground-based navigational aids and our approaches.
Mm-hmm.
And so I felt like I was mixing up. That's why with that first question, I was like, okay, am I screwing this up right now?
Yeah.
Because I recognize what my approaches are. Am I screwing that up with my ground-based navigation?
Yeah. So let's see. Let me find what day we first started talking about this.
I think it was the PowerPoint on Thursday of last week.
Wednesday. So
Wednesday?
Yep.
Okay.
So Wednesday, the navigational systems that you can see here. Here you go. So navigation system, these are ground-based, traditional ground-based. Okay. So NDB, the RMI, that's the instrument that uses the NDB. So these ones in parentheses, just disregard. But NDB.
So, but even that one said RNAV. And
yeah.
Okay, so I guess I was looking for specifically for ground-based navigation.
Yeah. So down
And
here.
so I kind of went out searching on my own and
yeah, so
kind of
down.
like coding it.
Yeah, no problems. Down here in the PowerPoint, it goes through the, and I remember saying this during the PowerPoint, you know, these are our ground-based navigational aids. So it starts off, the first section here is ground-based. So NDB, these, the ADF and the RMI are instruments, and you can see that, right?
Yeah.
And the ADF here. But then the VOR shows you the VOR types. Those are all ground-based navigational aids.
So the VOR, VORTAC, DME.
Uh-huh.
Okay.
All ground-based.
And then that's where I got screwed up because DME ARCs, I associated as a type of approach.
Yeah, so that would be an approach. Yeah, exactly. And then I believe this is where I said that these are our satellite types. So I remember talking about it, but I'm, you know, as far as clarity, I'm, you know, that may have been my mistake on that. I'm sorry about that.
Wow.
No, and it's just kind of tough to gauge because I know that there have been times when you've said, this slide isn't relevant and this isn't where it should be, or this should have said something else.
Mm-hmm.
And so I just need to I think I just need to stay more on top of that. And I've been trying to go back and rewatch the YouTube videos and
Yeah.
Mine was just, I just kept on getting ground-based and satellite all mixed up,
yeah.
is what my problem is.
So satellite, really the important thing to help you distinguish satellite, anything with a G, right? So GPS, GNSS, that the G means global in those. And then when we say R, so it's going to be either a G or an R typically. So
well, and I had RAIM down too in my notes, but
yeah.
when I had written that down, it just seemed like a receiver, like it was like a check system.
Yeah, exactly. So the RAIM isn't satellite navigation. A RAIM check is just checking the satellite signal.
Working.
Yeah, it's just making sure that the GPS system is good to go, that it's reliable.
Okay. I just wanted to make sure that I had that written down correctly.
Yeah. So RNAV, RNP, and then GPS, GNSS, satellite.
Okay,
And as long as you can remember those, you know, you're
so
good.
satellite
You're good to
is
go.
G and R.
G and R. Okay.
Okay,
And then VOR, DME, VORTAC, NDB. You also have the ILS, localizer.
okay.
Like any of those are going to be your ground-based navigational aids.
Okay, I still think I'm going to go back and rewatch this one from last week Wednesday because I think it'll be helpful for me.
Yeah, and then, like I said before, the good thing about the YouTube videos is we also have Adam's classes on there, and maybe Adam says something that rings better with you than something that I say. We have a little bit different technique, and sometimes things are better relayed with him than me. So it just depends on the subject. So watching both can really really help you.
So I have one more question actually.
Uh-huh.
So are non-precision landings mainly ground-based?
Yeah, so and that's a slippery slope too,
Yeah,
because
because ILS is precision, right?
exactly.
Okay.
So that's a slippery slope to go on. But
It's also where I got crossed too on that, I think.
yeah,
I was
so
thinking GPS was precision and ground was none, and then I'm like, well, ILS is ground, but it's precision, so maybe it's GPS. And so I just kind of
yeah, so the important distinguishment that you got to make is what is it providing, and remember that the ILS is going to be your primary precision approach, right? RMP, types of RNAV, those are going to be your other types of precision approach. But remember that it's providing both the vertical and lateral. That's really what you got to remember is vertical and lateral. And then when you look at the charts between an ILS versus like a VOR approach, looking at the minimums here, that's where you're going to see a huge difference. As long as you can remember precision, lateral, and vertical, lower minimums, that's really going to help you in the long run. Let's see. Let's see if I can find an airport really quick that has different approaches. Let's go into St. George because I know we use an LDA in St. George. So yeah, so like this LDA approach.
Will you expand that a little bit, Garrett, please?
Yeah. Let's see. See if I can zoom in here. So this LDA approach, oh man, it's too big now.
Your fancy Mac.
I know. It's okay. There we go. Now we're zooming in. Okay.
Okay.
A lot of times it's going to have a lot higher minimums than your ILS. Okay. So.
Okay. Can we see the ILS for St. George?
Yes. Actually, St. George doesn't have an ILS,
Oh, okay.
but we can look at Las Vegas ILS.
Okay.
Even the new airport wasn't installed with an ILS.
Nope, just an LDA. All right, so here's your minimums for an ILS. 300 3/4.
Okay.
That's a little bit higher minimums for an ILS. I mean, I guarantee you that they have a lower minimums one. Gosh, I hate these NACO charts.
Is this a NACO?
Yeah,
I'm looking at this. Is this a NACO chart?
yeah, it's garbage.
Okay, just making sure I'm not losing my mind.
There's 200 3/4 there. Can you see that?
Okay, yeah.
So the lowest ILS for a category 1 is going to be 200.5.
Okay.
And that's what you're typically going to see when you're talking ILS for minimums.
Okay.
So just depends. You can see this, just to point out, like GNSS. GNSS is required to fly this Q route.
Right.
So you'll see that every once in a while. On these maps, you'll just see different things identifying you have to have this in order to fly this. So that's where we're going to see it. And you know, going back to satellite navigation, you can see it's on a Q route. Q routes we automatically associate with satellite. Q routes, T routes, you know, satellite-based navigation. Whereas J routes and V routes, jet routes and Victor routes or Victor Airways, those are ground-based. So
going to be ground-based, right?
Mm-hmm. And you can also see that the satellite-based is blue, whereas the ground-based is in black. So.
Is that just how it's going to show up on Sky Vector, or is that how it's going to show up on all charts?
So what you're seeing here is the actual chart that, whether it's paper chart, you know, Sky Vector, whatever, this is the actual high chart.
Okay. I feel like I need to start back at last week Monday and watch everything all over again.
and no worries. I mean, like I said, you know, maybe there's some things that I need to change, but also remember.
No, I think it's just me. I really do, Garrett. Like these are all, like, the terminology is all familiar to me, and that's kind of where I have the advantage. So I don't even know, like, Cody, you have no aviation background, right?
Other than watching them.
Okay, so like the terminology is all familiar to me, where I know what an APU is and a GPU, and I know what winglets are, and I get thrust and all of those things. But when I look at a chart and it's completely foreign to me, this is where I kind of feel like I need to go back to last week Monday and start looking at navigation and air classes and all of that again, so that it's not so foreign to me.
Yeah,
I feel like I'm learning Japanese right now.
Don't feel like you're alone, even though I've seen some of these charts before. I haven't seen these Sky Vector charts ever, so a lot of the stuff is Japanese to me also.
I mean, it's super, super helpful that we're really focusing on the things that we're going to be tested on. And that's the thing that's key for me, is that I know that we're only focusing on the things that we're going to be tested on in our practical and that we're focusing on those in the quizzes. But I would like to know what each of these things in the chart mean.
Yeah.
Like how the big bold arrow means that's my highest elevation point on this chart.
Yeah. So
I like that.
Also, just going back to last week's stuff as well, these extra YouTube videos,
For sure.
these two right here, are really going to break down these charts for you guys.
Okay.
That helped me. Those videos actually helped a lot when I was watching those.
Yeah.
Okay.
So, and another thing to remember is, yeah, we're focusing the things on the practical, but remember the things on the practical are the actual, it's called the practical because that's the dispatch job, right? Yeah. This is the practical application of our job. So that's what we're focusing on. I just want you guys to know too that you are drinking from a fire hose, literally. I mean, there's so much information getting thrown at you over this course that it's really hard to take it all in. And I'm not trying to intimidate you, but it just amps up when you actually get hired onto an airline, because then they go into the specifics of why we do things, or what are the differences between what you were taught and what we do here.
Right.
So I'm not trying to intimidate you, but just understand that there's people that have done this course. There's people that have done this course and then gone straight into ground training. It's completely possible. And we're going to help you as much as we can. But, these after session meetings are good. If you guys need extra time, please let me know. And I'll help direct your studies a little bit more. But one more thing to just kind of touch on is remember that my reviews, if you remember the review itself, I'm hitting all the questions in the test. So once again, those thorough note taking during the review especially is really going to pay off dividends. So
sure.
Yeah, but if you guys need the extra time, or if you guys need a little more explanation, I'd be more than happy to dive into the deeper, darker parts of aviation to help you uncover why we do certain things. So
I appreciate you taking the extra time tonight. I'm going to jump off, Garrett. Thank you.
Yeah, no problem.
So much, Garrett. Thank you so much.
All right.
Yeah, thank you.
No problem.
Good night.
Good night. Any more questions from anybody, or? All right.
Yeah, Garrett, I did have a question, and it's kind of along just filing the flight plans and kind of your job. I know it's not what we're looking at necessarily right now, but when you're at work and you're putting together the flight plan and the release, you submit it so that the pilots can see it, and then I know that one of the submissions has to go to the FAA. And is that still, I guess I have a couple questions. Is that submission to the FAA still going to the flight service station in Cedar City, or does it just go into a national database? And anyways, I'm just wondering just the kind of how your day goes when you're just doing one particular flight release.
Yeah, so, man, it's really hard to explain here, but yeah, so whenever we file our dispatch release, like I said, the ATC strip goes to air traffic control. The rest of the dispatch release, even the ATC strip, all of that will go directly to ops and the pilot. So the pilot and co-pilot, they have their they actually use a Microsoft Surface tablet now. We call it a EFB, electronic flight bag. It'll actually pull up on their EFB and they can look at the release. But the ATC strip goes to flight data, which is at the origin. It's the flight data for the origin airport. So, like, think about like St. George. When we file a flight plan with St. George, it doesn't go to Salt Lake. It goes to LA Center because we are actually under the jurisdiction of Los Angeles in St. George. So Los Angeles flight data actually receives the flight plan, and they're the ones, the FSS, they're the ones that are actually going to initiate the flight. We contact and talk to LA Center prior to, or really it's LA departure control. We talk to them and make sure that we are good to go before we even start taxiing. And then once we get the clearance from them, they'll send us over to departure. We don't need ground because we're not in LA, but they'll send us over departure and we'll start talking to departure at that point. So it's dependent on the location at the airport and what jurisdiction it's under. As for what we do in dispatch is, it's really, I wonder if there's like a screenshot of Sabre. We use a flight program. Actually, one more word here.
Is it the Sabre system is it United or American uses Sabre? Michelle, do you use one of them, don't you, or both of them?
I think Sabre is, I want to say United.
Is it their system, Garrett?
Yeah, so Sabre, I don't know which of the majors use it. I think it's it's used with several airlines actually, but yeah, it's pretty popular as far as the dispatch world. Pretty common system. I know if you have Sabre time, like Sabre Experience, that some airlines like that and heavily weight those that have that Sabre experience. I'm not seeing a screenshot of the actual Sabre system, but anyways, kind of going over what we've talked about in the past, it kind of looks like this as far as like having these tabs across here. We have one that so it starts off with our load. We have load, then weather, then NOTAMs, then remarks, alternates, the MTOW box, and then the CFP, so calculate flight plan, the release button, and then the send button. So basically we go starting from left to right. We'll go and we'll click on each one of these boxes and it'll display the information pertinent to that box. So when we click on load, it'll pull up the payload, how many passengers we plan on having and how much weight we're planning on it weighing, when they get everybody on board. So each passenger has a specified weight depending on whether or not it's wintertime or summertime. And then they also apply a bag. So each passenger weighs right now 195 pounds. Actually, 190. We just switched to summer weight. So 190 pounds, and then we automatically apply a 30-pound bag. So each passenger we calculate each adult passenger we calculate at 220 pounds. And so it'll add up how many passengers we have and give us a load or a payload calculation. And then we click on weather. It shows all the weather information for the departure, destination, alternate, and everything in between that's pertinent to us. The winds aloft, things like that. And we just make sure that it's attached. Then we click on the NOTAM button. It'll display all NOTAMs pertinent to our route of flight. Then we have a remarks button where we can type in notes. Then the MTOW box, or the alternate selection, I kind of broke that down the other day where it'll show us the weather at the destination airport, and then it has a column of airports that we can select from and see the weather at those airports and make sure that we're legal, whether it's the destination or the alternate airports.
Interesting.
Yeah, and then once we've done that, we go into an MTOW box and we actually look at runway information. We'll look at, is it a wet runway? Is there contaminants on the runway? And it actually plans the performance for each one of the flights, how long the of a runway we're planning on taking off on or landing on, things like that, that we'll go through. And then flight plan. Once we click on that box, basically all it does is takes everything that we've put together and puts it into the flight plan and populates that, basically. And then the release button generates the actual release that we send. So, yep.
Did you mention there's templates for flight routes, so that you're not having to kind of rebuild it, every day? Didn't you say there was some plug and play of routes, say just Denver to Salt Lake? It's kind of in the system, or are you kind of building it each time? You just have done it a million times, so you kind of know what to plug in, or how does that work? Is it on you or an automated system, I guess, is what I'm asking.
So it depends. There's times where there's weather and route, and we just kind of have to build our own route. And then there's times where there's just not an already planned route, and we'll have to build it. But for the most part, yeah, all the routes are automatically generated in. So we have what we call company routes or preferred routes, that we've had our air traffic control guy go in and he's built the route, and that's the route that we use. But then we also have, different, depending on the airport, we'll have like CDRs or playbook routes like we talked about yesterday, where depending on what air traffic control is doing, we'll have just a handful of different routes to accommodate those CDRs or playbook routes. Really it just depends. Like, is it something that we are going to have to kind of make up on the fly because of weather or system on the aircraft being out? Or is it something that we're going to, that basically air traffic control's issuing us? But company routes are 9 times out of 10 what's going to be selected for every flight. We'll just have a handful of flights throughout the day that may need something a little bit different. So,
see, I appreciate that. Kind of helps me. I've got bits and pieces of the information, having been around it, but I didn't know this is all kind of new to me. A lot of the elements I'm familiar with, but I remember one day we were in Salt Lake and the system was down and nobody was getting their releases. That included Delta. Mm-hmm. And one of our pilots, I think it was the crew I was with, recognized, hey, well, we can just get it through the flight service station or something like that. and we were pushing back, and other guys were on the radio like, hey, how come they're pushing back? How did they get theirs?
Yeah.
But I don't know what was behind all that, but I just remember one guy says, well, wait a minute, let's just go old school and we can start this thing up. Let's get going here. And everyone was within minutes, planes were taxiing again because they figured it out. And I'm sure I guess they went through the flight service station, and I'm sure they got really busy all of a sudden on what would have been otherwise a quiet day. But I don't know what happened behind the scenes there. I just know that some part of that played out like that.
Yeah, there's different tricks and tips that we can do that will help. Sometimes the system's down at the airport and they're not receiving their releases. Well, on SkyWest Online, we can pull up any release. That's how I've showed you guys the different releases. It's all published on our online page, just so anybody can pull those up. You can pull it up on your cell phone. In fact, I typically do on each one of the flights I'm on. I'll pull up the release and just kind of look at it, But yeah, if you want, I'm more than willing to have you come and sit down. You can get a real good taste of what our day consists of. So
I would like that. I'm in Ogden right now, and I'll be here for the next couple of weeks as we take the class. But is it something we could kind of arrange when we come into town in those last 2 weeks? I would love that.
Yeah, definitely.
Fantastic.
Anytime that you can come down and jump on, even if I'm not there, I can set you up with somebody that would be willing to show you the ropes. So
I appreciate that. I'd like to see it.
Yeah, no problem.
Well, I appreciate you taking the time. I hope I didn't interrupt if you had questions, Michelle, taking all your time.
No, I like that. I like the step by step of kind of what we're doing. So that did help a lot.
Yeah. So do you guys have any more questions or anything I can help you with?
I actually didn't have a question, but maybe for the future, I came across a video when I was looking at our YouTube videos. Somehow, in the sidebar, there was one on a flight that was an Allegiant flight a couple of years ago, and they were going into Fargo, and you may have heard about this. And it was just something to talk about, really not. But I was wondering, wanted to get your take on it. So this flight took off an hour late, going to Fargo, and they ended up running out of fuel. They had to declare an emergency going in there. The problem was the Blue Angels were there on a Thursday preparing for their weekend show. So so the airport was closed, and it was daily while they were doing their leading up to the air show, plus the day of the air show.
Yeah.
And it was a real stir with ATC, and you can look it up, ATC and Allegiant. They had this argument about, hey, you knew that we were closed and now you're out of fuel, and now you didn't even have planned for an alternate. And there's a lot of details that would involve a dispatcher, the pilots, and now the ATC is involved, and they're not pleased because it's messing up what they had planned for months. It's not something that was planned in a few days prior.
Yeah.
Anyways, someday I'd love to get your take on that if you ever get a chance to see it, and I'll email it to you if you want. Maybe you've seen it or the whole situation, but I'd love to hear about it, kind of your eval.
Yeah, for sure. Send it over.
I'll do it.
I love stuff like that.
It was interesting as I thought about it. There's a lot of people that have their hands in that, and it ended up with a flight, declaring an emergency for lack of fuel.
Mm-hmm.
And there's a lot of reasons that shouldn't have happened, or they should have had an alternate. And I don't know what all of those elements, but anyways, I'll send it to you. See what you think.
Yeah, for sure.
Well, thank you again.
Yeah, no problem.
Yeah, thank you.
No problem. All right, you
Good
guys
night.
have a good night.
You
You too.